All right, hey everybody, and welcome to Python Selenium Fundamentals to Frameworks. And we'll be using the SeleniumBase framework in order to tie everything together. I'm Michael Mintz, and welcome to Chicago. All right, so a few shout outs for starting. I'd like to thank the Selenium org. They created Selenium, and of course the conference organizers are doing an awesome job, maintaining everything. My wife also supports me in a huge way, and she even came out today to watch. And iboss, my employer, they support my work, and I use the SeleniumBase framework all over for their cybersecurity automation stuff. So yeah, I am the creator of SeleniumBase, and I also lead the automation team at iboss. So I'm going to quickly jump in and talk about what's going on. So this is the only dedicated Python session at SeleniumConf. So I'll hopefully be holding the Python ecosystem on my shoulders. And you're going to see lots of Python, a lot of live demos. And if the one session is not enough, come see me afterward. There'll be a lot more to come. So by the end of this presentation, very important, you're going to learn a bunch of things. So Python Selenium fundamentals, we're going to start with the basics, so things that you may not know if you don't use Python at all. If you already use Python Selenium, then we're going to evolve that into something more advanced, and we'll get to that later. So we're also going to find out how SeleniumBase can make Python web automation easier. All right, so let's move in. The format is a lot of slides. They're going to be GitHub README files that I'll go through. And of course, lots of live demos, some videos with automation, some actual demos, assuming the internet connection does not fail. We can run some real automation on real websites and see how things go. So it should be exciting for that. So let's start. What does Selenium provide? It's an automation library. And it says so right on the website. It automates browsers, but it does not provide a test framework. That's where all the other people come in. Developers can write test frameworks on top of Selenium to wrap it and make Selenium a lot more powerful than it is on its own. So how do you get Selenium if you're a Python user? Well, there's this really cool tool called pip. If you've downloaded Python or installed it, it's going to be available from the command line. And you can install packages using the pip installer. So just do pip install Selenium. And then all of a sudden, you've got the latest version, which as of today was 4.8.3. So what are some of the building blocks of basic Selenium that you get from installing Selenium? Well, of course, there's importing the library. That is the main line that you want in most of your programs. From Selenium, import WebDriver. You've got that. You've got access to the Selenium library and all the Selenium methods that go with it. After that, you can spin up a web browser. And for instance, let's say we're using Chrome, but you can also do automation with any of the other browsers, such as Firefox, Edge, even Safari. So that is the main command, a very simplified version of it, for spinning up a web browser. After that, you've got the driver.get command, which allows you to just open any URL on the internet. And in that particular example, your web browser, after you've opened Chrome, is going to take you to selenium.dev. So basic building block. We'll cover the basics so that you know what they are, and then we're going to get a little more advanced. So here's the command for finding an element. And first you have to specify what type of selector. So you could have an XPath or CSS selector. Normally, you would import the by library and do by.cssSelector, but that just translates into that. And then if you're using a CSS selector, you can then specify the CSS selector. And this is going to find the element and then return a Selenium web element. Once you have a web element, you can then say element.click as one of many different APIs available to you to say, click on that element. Let's say you also want to find an element and then type text into it. Well, there's another method. It's called sendKeys. So once you've found your element using driver.findElement, you can do element.sendKeys and then the text that you want to type into the text field. And then another basic command, driver.quit, which quits your WebDriver at the end so that you can free up resources and not have like 100 different browsers open if you keep running the command but not closing your web browser. So launching a browser can get a lot more complicated than just webdriver.chrome. There's lots of different options that you can specify, and you can use all the same options that are available from regular Chrome. So for instance, you can disable notifications, you can add experimental options such as the exclude switches, which lets you like set something else, enable logging, enable automation. There's hundreds of different options that you can specify, and you can even change, like say, the password manager and not enable that, etc., or the credentials enable service. All these like are built into Chrome. So if you want to take control of a web browser and like change the settings, this is like one way to do that. And then you do driver equals webdriver.chrome with the additional options that you want to put in. So that's a typical example of advanced options where you want to do more than just spin up a web browser. You want to set all the configuration, and it uses the browser for that. So up next, test frameworks can wrap Selenium in order to improve things and give you a lot of additional behavior. So in this particular example, this is right from the Selenium website. You have a test framework wrapping WebDriver, and then from there, you can add additional methods, such as driver management. And there are different tools that can wrap Selenium, such as WebDriver Manager, and that basically allows you to automatically download your WebDriver into a special folder so that the tests are ready to go, because before you can even start your first test, you need to make sure that you have the drivers, such as Chrome driver for Chrome, Gecko driver for Firefox, MS Edge driver for Edge. And I think with Safari, all you have to do is change an option, and then you can run your tests on Safari. So that's where frameworks fit in. So what are some of the disadvantages of using raw Selenium without additional libraries or frameworks? Well, the default timeout is 0, and a lot of people have probably seen this particular error message before, where if something goes wrong, you get a giant stack trace, and it's not very pretty. And you see just a lot of Chrome driver messages that aren't very legible. But this is like a typical thing where you try to just click on an element that isn't fully there yet. You get big stack trace. So this can be improved on and simplified. A test framework might wrap all that, and instead of just throwing a giant message like that, it'll just be like, this element with this selector is not visible after 10 seconds of waiting. So these are just some of the ways that a test framework can improve on the standard Selenium library. So the commands can get quite long with standard Selenium. For instance, driver.findElement, and then you have to specify the by, and then put the selector, and then .click if you want to click on a button. However, there are test frameworks where it's just self.click, and then you put the selector, and it will auto-detect between CSS selectors and XPath, because XPath and CSS are quite distinguishable. Like for instance, if the selector starts with / or // you're going to know it's like, okay, that's an XPath selector, because CSS can't do that. So because there's a difference between CSS selectors and XPath selectors, a framework could just auto-detect what the selector is and be like, okay, instead of specifying what kind of selector it is, just like immediately click the thing because it knows, oh, this is XPath and this is CSS. So that's just a few ways that frameworks can improve on some of the fundamentals. So self.click is better. So with raw Selenium, you're not going to get fancy HTML reports, the dashboards, like a special results display, even automatic screenshots. These are some of the things that test frameworks can build on top of Selenium so that when you run your test suite, all of a sudden you have like a screenshot for every failure instead of just like an error message. So there are frameworks that already handle this sort of thing. So here's an example of an HTML report that combines pytest HTML reports with the SeleniumBase dashboard, giving you a pie chart of your tests, stack traces in the logs, and of course, a screenshot from a XKCD website essentially saying, like, okay, this is the failure that was here, it's nice and red, and here's the screenshot of the last page you're on. So if you have a failing test, it can immediately say, okay, there's a problem here, here's the report that you got. You clearly see from all the tests that you ran what went wrong, and it's very clear what you need to fix. So more things with raw Selenium. It might take a lot more lines of code to perform the same thing that a framework could do with a single line of code. So for instance, with regular Selenium, you might have to first find the element, and then clear out the text field, and then do like send keys to like type in text. So for instance, that is how to log into the Sauce Labs demo website. And then you go into element.submit, and then that will like do a whole that'll let you log in automatically to the website. So a method like self.type, where you put in the selector, and then what you want to type in, and then use a \n, which will automatically perform a submit action. You can do all those 4 lines of code in 1 line of code with test frameworks, and this particular line is coming from the SeleniumBase framework. Basically, a few lines of code or 1 line of code can perform the same amount as maybe 4 or more lines of code from raw Selenium. So what else can test frameworks provide? Well, you've got driver management, and you've already seen at Selenium Conf there was WebDriver Manager. SeleniumBase also has its own driver manager, so it works pretty similarly. There are also advanced methods such as assert no broken links. So basically, you could have action, it checks all the links, and if any of them return a 404, it will tell you that and be an error inside your report. You also have test assertions such as self.assert text, so that you can check whether certain text appears in a selector on a web page. And if it doesn't, then you have a failed assertion. So this is an example of an advanced assertion that you could have. You also have additional command line options that you can do, and this is something really huge from regular Selenium. Normally, you'd have to modify your test if you want to like change which browser you're using. With a test framework, it might add a pytest command line option so that you can say, okay, instead of the default browser of Chrome, I want to use Edge, and then I want to add a HTML report on top of that. All of a sudden, you no longer have to modify your tests every time you want to change a little bit of behavior. You can change the browser and many other things right from the command line with a lot of these frameworks. And you've got advanced tools such as test recorders that will generate full scripts for you automatically, similar to the old Selenium IDE, but now a new modern version of that. Those might also exist within test frameworks. And you have easy-to-read error messages, such as element H2 is not visible after 10 seconds, instead of going back before where you had a giant long list of Chrome driver stack traces that was kind of hard to decipher, and you generally make you have to scroll a lot in order to see what went wrong. So up next, what about test runners? Well, Python is a very powerful programming language, and it has tons of existing test runners available to it. One of the most popular test runners for Python is the pytest framework. And it has lots of ways for automatically running tests from the command line, where you can specify a folder to run all the tests from, or a file, or even like a regular expression, so that you can only run the tests that contain a certain string within the name. So that's one of the cool things that pytest provides. So here are all the things that pytest can do. Auto-collect tests to run, as you saw, or you will see soon. You can use markers for organizing tests. I'll get into that in a bit. So you can essentially say, this test is A, this test is B, run all the B tests, run all the A tests, and all of a sudden you can organize all your Selenium tests quite easily. Generate test reports, you saw that. Provide test assertions, that's also available. You can multi-thread your tests by just saying -n8 on the command line, and all of a sudden it'll spin up 8 browsers. You'll see that in a bit. There's a large number of existing plugins already available to pytest, such as the pytest HTML, which generate reports. And there's a lot of additional ones too, such as for multi-threading support, and a lot more that we'll get into in a bit. So what about complete frameworks? SeleniumBase combines the best of Selenium, Python, pytest, all that into a powerful framework. And we're going to do some live demos for that in a sec. So you already saw most of these things. The features that I was covering before were actually from SeleniumBase, where you have the self.assert no broken links, assert text, command line options where you can just change your browser, easy to read error messages so you can see exactly what went wrong, and the reports, etc. To get that, it's just, instead of pip install Selenium, it's pip install SeleniumBase. So quite easy to get, and that is a screen from the GitHub page. So now that we've covered the first 15 minutes, just a few slides, we're going to start jumping into some GitHub README files, some live demos, running some scripts, etc. We're basically going to talk how we can evolve raw Selenium into something more advanced like SeleniumBase. But if you want to see a few examples of this running a test with SeleniumBase, let's run a quick test, my first test, from the SeleniumBase examples folder. And that ran pretty fast, so you might not have seen what it was doing, but there's a cool mode called demo mode, which actually highlights the browser actions so that you can see what the test is doing and what it's asserting at every step of the way. So you have element assertions, you have text-based assertions, assert the title, etc. The JavaScript will go right onto the page and show you exactly what it's doing. But if you don't run with demo mode, it just runs in like instantly. Like a few seconds, it does all those things. We're now slowing it down so you can actually see all the various things that are going on in this particular example test, such as adding a backpack to a cart, and then going through the checkout process, and then making sure that you've got the thank you for your order at the end. So let's take a look at what this particular test looks like. And then we're going to take a few steps back and take a look at how raw Selenium evolves into something like this. So if we open myfirsttest.py, you'll see it's just a simple command such as opening a web browser. Actually, let's see if I can make this a little bigger to see if you can make it easier for everyone to read. Okay, is that a little better for the audience? Okay, cool. So the spinning up of the web browser is done automatically, and you can change what type of browser you use. Like, for instance, if I wanted to run that with like a Safari browser instead of Chrome, I would just do pytest myfirsttest.py and then do -- Safari. And you can see that it's now using a Safari browser. If you look carefully at the top left, it is doing that. So that was it running in Safari. So command line options let you really control and customize the various tests that you have. So back to here. Here's a simple command for opening a web URL. Then you can type text into a text field, and then type in the password, and then the \n will give you a submit action automatically. So one line of code handled the 4 lines of code that you saw earlier. You can easily assert that an element is on a page, or assert exact text. You can click a link easily, or click an element like the button here. Click a shopping cart, assert exact text. So the difference between assert text and assert exact text is that assert text lets you know if the text is in the full text, whereas exact text means a full text match instead of a substring match. So yeah, lots of simple actions, but it performed a lot of things. And of course, there's also a JS click available instead of a regular click when you ever want to click something that is maybe hidden behind another element. Otherwise, you might get like an element click intercepted exception, or like another element was over yours. There's lots of different APIs that you can use for that. So that's just a basic test, and it's a lot more simplified because it takes care of the browser management. Now, let's take a look at how we evolved from regular Selenium to something more advanced, like SeleniumBase. So let's go over to the raw Selenium, and let's take a look at a flaky, messy, raw example where you have to specify, so quick step back. So there is a built-in framework for Python called unit test. And unit test case is something that test classes can inherit in order to gain additional assertions and they'll gain automatic setup and teardown methods like you see here, setup and teardown, which will be called automatically at the start and end of tests whenever you run that. So let's see if I can just make it a little bigger so you can see. So unit test provides automatic setup and teardown so that you don't have to call it directly from your test. It's automatic before and after your test starts and ends. And inside those setup and teardown methods, you can specify how you wanted to launch your browser. And this particular example, it's using raw Selenium, not SeleniumBase. So we're just using regular from Selenium import WebDriver. And all of a sudden you see that you have to define all those things, like how you want to launch your web browser, because that's not automatic, because Selenium on its own doesn't include a test framework that does all that for you. And of course, in a teardown step, you'll have a quit process. So you might then have to define your own methods, such as isElementVisible, and you'll check that if there is an exception returned after trying to do a self.driver.findElement action, then you'll return false. Otherwise, you'll return true if, say, the element is displayed. So when you're not using a test framework, you have to actually define all these methods on your own. And it can become a little cumbersome, but that's why test frameworks exist, in order to simplify things for you. So here's the test that we're creating here with raw Selenium. Test add item to cart. You're doing a self.driver.get action. You're gonna, instead of using the by.css selector, maybe you'll put that into a variable so that you don't have to type that in. And then you have to say element.clear, but maybe in this particular example, the text field was already empty when you went to the page, so you didn't necessarily have to clear it, but a lot of times you might have to. Send keys is the typical, type text into the text field and all that. And tests like this can be flaky because, or they're very long and messy, because you have to do the whole driver.findElement with specify the by, specify the selector, and then tell it to do a click. So that's what regular Selenium provides for you. And out of the box, this is what you'd have to do unless you were to define methods that do these advanced things. So as you can see here, the script is quite a bit longer than if you used something such as SeleniumBase, which does simple methods, all that for you. So that test does the exact same thing as this. Well, not totally exact, but the same thing, but it takes a lot longer to do the same thing with raw Selenium. And of course, the script can be flaky, because if any of these elements aren't loaded right away, you'll get like a stack trace and a failure for that. So that's the first step of raw Selenium usage, basic things, but let's say you want to improve on the flakiness level of that. Well, there are additional things such as there's the selenium.webdriver.support.ui, which includes WebDriver wait. So this is basically the next evolution of raw Selenium. A lot of people start using WebDriver wait in order to wait for an element to be available before interacting with it. So as you can see here, if we go into the test itself, you now have to say, like, to look for an element, you're doing element equals, say, WebDriver wait, self.driver, and how many seconds to wait for until the element, say, is clickable, or the element is, visible. And then you still have to specify the by.css, etc., and maybe the selector with that. And that takes up a lot of code, significantly more than just like a simple assertion. So WebDriver wait is one evolution of that, but it's still a lot more code to do. So you still end up with a really long script if you have to use WebDriver wait ec.element to be clickable after every single action. So that was like the first evolution of evolving. And then let's say you want to extract those out into methods themselves. Well, you can do that, and then inside your test, you'd call, say, wait for element visible, and that would just be defined as a huge WebDriver wait command. But instead of calling all this in multiple lines of code, you can now just do it in one line of code. So this is how we start to simplify the method, and all of a sudden, it looks a little cleaner than throwing WebDriver waits everywhere, and it's not as flaky as just trying to do a click directly, because then if the element doesn't load, you get a stack trace and a failure there. So that's the next evolution. After that, we have the refined raw, which basically really builds out advanced methods such as a click method. So you'll see that we'll first wait for the element to be clickable or visible, and then you get the selector, the by equals by, etc. So we're building out those original methods, and now all of a sudden we have a click method. So by the end of all these methods that we've built out, we've got a script that looks pretty much just like the Selenium-based version, but it's now using only raw Selenium. So as you can see here, it's just from Selenium import WebDriver and a few of the existing APIs that Selenium already provides. Using this example here, you've actually refined your tests to basically be a simple version of what you want. So that gives you something like this as the full test, and all of a sudden it's a lot more readable and easy to follow, understand, and make changes to it. So that's how you evolved something such as a raw Selenium building block into something that actually becomes easier to use. So now that we've basically taken the API from really raw to a more refined thing, SeleniumBase tries to simplify all that. And if we go to the repo, you'll see that there's a lot of advanced features such as dashboards and reports, etc. So let's say we run a different test. Let's do pytest test suite.py, and then let's do -- dashboard, and then -- HTML equals report.html. So this is going to run a quick series of 4 tests, and 2 of them will pass and 2 of them will fail on purpose so that you can generate the report at the end. So now, if we want to take a look at the report, open report.html. You get a dashboard, a pie chart, and inside here you have stack traces with screenshots. So you can see your click-in screenshot of that particular failure. That one was failing because the fake text was not visible after 0.4 seconds. So there are default timeouts built in that are probably like 7 or 10 seconds, but you can change that within your test. Here, the fake element was not present again, so the test failed on purpose, and you see the screenshot that gets generated. And so you have stack traces, screenshots, and of course pie charts. There's also a regular dashboard view. So if we go open dashboard.html, actually let's take that file and open it in here. You'll see that there's a logs and a data folder, but it's kind of small, so let's see if I can make it a little bigger. All right, so inside the data folder for like a failing test, you'll see a basic test info.txt file. I'll expand it so you can see a bit of what you get from one of these reports. So you'll have the test that it ran, the last page that the test was on when it failed, how long it ran for, the browser that you had, the driver that you were using with it, and hopefully the version of Chrome driver matches your version of Chrome. You'll also have the Unix timestamp, which is great for helping you debug the issue, and that converts into a regular date and time so you can see exactly when the test ran. And my clock is still on Eastern Standard Time, so it might be actually ahead of, it's actually 5:28 here in Chicago, so it's based on your computer, on the computer's clock. So if your computer's clock is wrong, it's going to match that. But you can always sync it up with UTC, etc., so that you know where exactly you are. You have a nice trace back in here where it says, okay, fake element does not exist, was not present after 0.4 seconds. So that is cool. So that is basically the dashboard and the HTML reports functionality. You also get a screenshot in that particular log, and you have the whole HTML file, which you can then take a look to see if there are any failures that occur. You can look at that easily. Works great with build systems such as Jenkins, etc. So the next part, let's take a look at some of the cool command line options that you have. Actually, first, if you just type sbase on the command line, you'll see a whole lot of different things that you get out of it, such as the methods, common options, the GUI, recorder, the ability to print tests right from the command line, etc. So if I do say sbase print basic test.py, it's just going to print it, which is good so that you can see exactly what is inside your script. You can do -n to print it with line numbers. Cool. So if you type s-space methods, you'll see a lot of common methods such as clicking links. You can click checkboxes easily with check if unchecked, so that if the checkbox is unchecked, it will automatically check it. You can grab the page source easily. You can do drag and drop, hover and click, select option by text, switching into an iframe easily. Lots of different assertions that you can use, such as asserting that there are no 404 errors, there are no JS errors, etc. If you type s-space options, you'll see lots of various command line options that you can use, such as changing the user agent, changing the browser, using demo mode, maximizing the window, using the dashboard, using a pytest collect only run, incognito mode. So if we run back the test suite that we ran a moment ago, you saw that it opened up a new browser each time. There's a --rs, which stands for --reuse session, which means it will run all those tests in the same browser window without having to spin up a new browser window each time, and that will save a ton of time. Also, there is the ability to multi-thread those tests. So if we ran the same thing and we did -n4, you'll see that it's going to spin up 4 different browser windows instead. So you can easily do multi-threading and all that. There's also a very powerful tool called the recorder. So let's open that. You see a little tool that comes up. So let's do saucedemo.com and then do a record. So I can basically record actions. Let's do standard user and then, so right now I'm typing this in so that the recorder records the script. I'm going to add 2 items to the cart, and then I'm going to click on the cart, and then I'm going to click checkout, and I'll put in like fake name 1, 2, 3, 4, 5, continue, and then finish. And then I'll do Shift-7 to switch into assertion mode, and I can assert that the text is there. And when I'm done, I get to go back to the command line, which was here. Here we go. So you see it created a breakpoint. So if I do C to continue from the breakpoint, you'll see that it generated a full test out of just the actions that I did. So instead of actually having to manually create all your tests, you can use the SeleniumBase recorder to instantly generate the entire test for you. So now, if I run that, I can do playback, and it's going to play back the exact same thing I just did. If I do playback in demo mode, it's going to slow it down so you can see what exactly you created. So here, now it's adding those exact same items to the cart, and now it's verifying the cart. Typing in the fields, it'll automatically generate a full Python test for you, just like that. With a few clicks, you don't have to even know all the APIs. You can do all that for you, which makes it a lot faster and easier to do. So that's the SeleniumBase recorder, a really fast way of just generating tests on the fly. There's also plenty of other advanced features, such as the presentation generator. And if you hadn't noticed, the presentation that I ran earlier, this was all built in Python. So if I open the presentation that I ran earlier, I used SeleniumBase to generate the Python, or to generate the JavaScript from the Python. So if I did pytest fundamentals.py, it's running a Python script, and that generated this entire presentation that you see here today. So some of the advanced tools that you'll have here is the ability to not just do testing, but you can generate presentations, you can even generate advanced charts. I'll quickly show you that. So if we go to the chart maker, which is from the SeleniumBase examples folder, and do pytest chart presentation, you'll see that you can generate a pie chart with regular Python, bar chart, column chart. You can do fancy animations like that. There's even a website tour maker. I'll quickly go for that. pytest maps school intro.js tour, where it uses pytest to run some Python code that automatically hacks into Google Maps. Well, not really hack it in. It changes the browser that sees it, and you've now added a website tour. So as you can see here, you can use the SeleniumBase to not only do tests, but create a whole website tour, and then you can export that into the JavaScript file, and then load that directly into your website. As you can see here, tour is exported, maps intro.js tour.js, so the Python generates like a whole website tour for you. So that's just some of the cool advanced things that you'll have here. And there's a ton of stuff on the GitHub README page. And if you haven't started the GitHub repo already, please do. There has all the instructions that I didn't get to cover today, such as various formats. And there's multiple syntax formats, such as the regular base case inheritance. I'll just make that a little bigger so that you can see that's like a standard way of doing it. But it also can handle things such as pytest fixtures, where if you load SB, and you're familiar with pytest, you can run everything as the SB fixture. And another common one you can do is the context manager, or even the behave BDD Gherkin syntax format for people who are familiar with that. So you can also use the SeleniumBase recorder to record this exact same BDD-style Gherkin test as seen here. And you'll have to do that on your own, because I am running out of time. But to end off, I am going to play a video that I basically used SeleniumBase to generate a automation that modified several different websites. So this is SeleniumBase going in and hacking, say, Apple, Google, and like all the various websites you see here with automation, because Selenium has the ability to execute JavaScript in the web browser, which means you can easily modify any text on any website page and even create like a music video like this. So this is actual SeleniumBase going in with the demo mode as you saw and changing the various texts that you see. So that was like GitHub. And it's going to go through, and here is like the dev.to. It just goes through and just changes all the text. So as this plays, I basically want to say that SeleniumBase can do the test automation, instantly generate your test, but generate presentations, charts, website tours, hack websites, but it's only hacking your browser, not so much your website. And as you can see here, it's just going through, and this is actually one of my most fun videos that I created, where just, okay, can I just go on to like every single major website and just change the text? And actually, I think a few of them thought they were actually hacked, because like they saw the video and like, wait, call security. Oh wait, no, that's good. It's just someone messing around with their browser. It doesn't actually hack their website. But with JavaScript, you can do anything. And SeleniumBase basically utilizes the best of Python to generate a lot of JavaScript to do advanced things such as demo mode and all that. So yeah, this is the last part of my presentation of the 2-minute video where you go in and you probably recognize a lot of these websites. There's like Slack. And if you want to see what the script looks like, I'll quickly show you what that looks like at the end. Take a few seconds once this is over. But yeah, here's the Selenium website. As you can see here, Selenium automates browsers. But what you do with that power is entirely up to you, which means if you want to use that power to make a music video where you hack a bunch of websites, then that is power to you, and all the other things that you want to do. All right, that should be less than 20 seconds away from completing. That's the pypy.org website where you download Python packages such as Selenium or SeleniumBase. Probably recognize Atlassian. Oh, there's one for iboss. And Treehouse, and then it is ending. And the very last thing I'm going to show you is the script that I did for that. So I'm going to open up that script so you can see exactly what that looked like. Open hacktheplanet.py. And here is the cool method that you pretty much used everywhere, set text content, which allows you to change the text on any website. All right, cool. Well, if you have any more questions about SeleniumBase, check out the GitHub page. And also, because this is the only real Python session at the conference and you want more Python and more cool awesomeness, come see me. Even tomorrow, I might do like a small, find a room somewhere and then show more advanced features such as more dashboards, reports, and all the other API methods and command line options I didn't get to cover today, such as how to change your proxy server or other additional settings that you can do from the command line when you run a test. All right, let's open the floor to questions. They're going to pass around the microphone to anyone who has a question, and yeah, please ask. And raise your hand if you have questions. The microphone guy will come to you.
Hey, great presentation. Thank you. We generally, when we use the Selenium as an UI test framework, now one of the main stale exception what we see. So from the Selenium base, is there any way it automatically detects the stale exception?
Yes. So with the SeleniumBase API, it's automatically going to avoid that because it's always going to refine the element when it does its automatic weighting. So if I were to go into the code right now, so this is just the big SeleniumBase with all the different things. Inside the API, which is located at SeleniumBase fixtures basecase.py, if you go into that SeleniumBase, that's where like all the real major code lives. Base case, that's what you inherit. You'll see that whenever you're finding the element, it basically does, let's see, find elements. It calls a method, and it loops through. Actually, there's a lot of code in here, so I'm not going to search through all that now. But essentially, you're not going to run into the stale element reference exception because if you try to do a click action and the element isn't immediately there, it will automatically search for it. So I'll run a more advanced thing quickly as I answer more questions. Pytest, coffeecarttest.py --rs. So it's going to basically wait for the elements to appear. So here I am ordering some fake coffee from a fake website. It's going through, and it doesn't run into any issues even though things don't load up right away because it has a default timeout of, say, 10 seconds. And if your element is going to generate like a stale element or that, it's just going to refind it. So you don't have to worry about that. That's one of the things that's wrapped within the framework.
Thank you.
Yep. Next question.
We're pretty much out of time. We got time for one more question.
Sure. Oh. Cool.
Thank you very much. Having built some frameworks, also very impressive to see your stuff. One thing that I haven't seen in your demo is kind of the page object model that testers tend to use. Yours is very scripty, and so just curious your thoughts on page object modeling and yeah.
So there is a format where you can actually structure your tests using the page object model. So if you go to syntax formats, you go to page object model with base case, you can basically define something such as like a login page and then call the login page methods like this. And it's actually one of the 23 different formats that you can use for structuring. So if you want to basically break out your tests into page objects, I assume something like this, like a login page, and then you want to call a method from that, you do something like that in this way. And it just has examples of using, I'll just zoom in if you can see. So page object model would look like that. There are a few other examples so that if you want to break out all your selectors into a page objects as well, there's an instant page object model generator. So for instance, I'll quickly, if I open basic test.py, you see it has the selectors in there. If I do Selenium sbase objectify basic test.py, so it's going to create a page objects file for it, and then it's going to update basic test. If I open that, you'll see that it broke out all the CSS selectors into page objects, and you can like change the naming of that so that if later you decide, oh, I'm going to be reusing this selector a lot, why not just break everything out? You can use some of the really advanced command line tools, such as the objectify command, and you'll immediately break out all your CSS selectors into an objects file, and then the script will run as is. And you can even like translate, similar to how we swapped your selectors with that, you can translate the API into multiple languages. So let's say if you want to have SeleniumBase in a different language, there's like for instance, Chinese translation. So it's using Chinese characters because there's a one-to-one mapping from all the SeleniumBase methods to every other language. So if you want to actually run your test, there's a translator function. So you just do space translate, and it'll immediately translate your test into that language. So if I do space translate, let's see, coffee cart test.py, and then I do --zh, which is the Chinese code, and then do -p to print it out, you'll see that it translated a regular test into a different language. So if you don't speak English, that's cool. There are 10 different languages supported. Just do space translate the language that you want. Like there's like French, Spanish, Portuguese, Italian, Japanese, Chinese, Korean, all that. You can instantly translate a test so that your team back in, I don't know, Japan, who maybe doesn't speak perfect English, they can see, or in this case, Chinese, they'll be able to see all the API methods with the one-to-one mapping and instantly translate, and it'll run just like any other test because it does the replacement on the fly. Thank you. Yeah? Any other questions? All right. Well then, come see me afterward if you have any more, and I'll show you more advanced things that we did not get to cover today. But thank you so much for coming to Selenium Conference Chicago 2023.